notebook that will be working on and creating. Okay. Okay. Let's just rename it to dog breed, or let's just say deep learning. Okay. Okay, so topic is already written and you guys can see it. What is the topic name? Okay. I'll add basically this is where I get the data from. Okay, you can download all the data from the from Kaggle, and let's just start looking into deep learning. Okay, cool. So first thing first, okay. Hello. Did someone say anything? Because like I want you guys to be on mute. Why do multiple people have permissions in here? Can we not have permission for everyone to speak up? Because it would be a bit annoying. Okay. Cool. Now, before we go into deep learning, I want someone from you guys to at least like define me. What do you guys understand by deep learning? Define me what is deep learning? I mean, it can be right, it can be wrong, it doesn't matter. Like a basic understanding, what you guys understand. I mean, if you say working with neural networks, then what is neural networks? Modeling data like photos, deep learning, a subset of machine learning. You guys are giving me skewed definition. Nope, 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 nope. Okay, I'll tell you. So, deep learning, okay, is type of machine learning that we all know, okay? It uses artificial neural network. Sir, mic is not disabled. Am I audible or not, guys? Are you guys facing any issues hearing me? Okay, I'm audible. Okay, cool. Okay. It uses artificial neural network. Cool. This is clear. Now, what are artificial neural networks? Basically, artificial neural networks here, okay, are inspired by human brains. I mean, please, someone from Blackbucks, can you mute everyone else? I see people making noises, which is not so good. Can you mute other people, please? Okay. Neural networks are inspired by human brains, and they can be used to obviously solve a wide variety of problems, including image recognition or NLP or speech recognition. Okay. Sectors it can be applied to includes but not limited to are NLP, image recognition, speech recognition, and so on. Okay. Now, usually deep learning models can be taught to perform classification tasks and recognize patterns in photos, text, audio, and other various data, right? And these models are trained on large data sets of pretty much usually labeled data, which allows them to learn the relationships between different features. Correct. This is what we have been doing and we know about it. Nothing special. Cool. Cool. There. Okay. Now, what are we using? What are the most common libraries to actually do machine learning on? Okay. So you already remember by now our 6-step model, right? Which is this one that we have been actually uh, looking at for so long now. What the hell? Wait. We have been looking at this model, right? Okay. This is the same model that we follow in here also. We do data collection, we do data modeling, we do deployment. Okay. We define problem definition, we collect data, we evaluate, we define features, we do modeling, and we experiment. Nothing new that we are going to do. We are basically following the same procedure. The only thing that is different is we'll be using TensorFlow as a tool, okay, to perform deep learning. Okay. Now, there is another tool that you can use if you don't have a strong GPU. Okay. I won't be showing it on that because I have a strong GPU where I can perform some tasks like these. But you can use something called as Google Colab. Okay. It is not a rocket science. It also works on Jupyter Notebook. The thing is that it is limited, but you can actually store a limited set of data in your Google Drive, and from there you can actually run your models and experiment with it. Okay. Obviously, we won't cover this. So note, you can use Google Colab if you don't have a strong GPU. Okay. Now, what is TensorFlow? Okay. So what is TensorFlow? Any ideas? Anyone? Any ideas? Anyone? Topic name is always written at the top of Jupyter Notebook, guys. Okay, it's not so complicated the way you guys are making it complicated. The idea is TensorFlow is just a library. Okay. TensorFlow is just a library. It's just a library that we use. Okay. Um, for developing ML applications and neural networks. That's it. Okay. Smarter rocket science. Um, cool. It is developed by Google, obviously. And the first version that came of TensorFlow was in 2015. And since then, we have actually come too far now. We have done a lot of things around it, but it is highly popular. Okay. It allows developers to actually create data flow graphs, obviously, but we'll look into it. What else? Helps us work on unstructured data. Okay. Now, why TensorFlow? So, one, we need to write fast, deep learning code in Python. It has first-class Python support. That's why. Okay. And able to run on a GPU. What is the GPU, guys? What is the GPU? You guys are computer science student. Most of you guys are gamer. Tell me, what is the GPU? What is the GPU? Graphical processing unit. But what is the graphical processing unit? What does it do? Oh, what does it do? I didn't ask the full form of it. I asked, what does it do? Mathematical computation, graphics and effects. What else? So basically, okay, I'll tell you what it is. It's obviously it is an electronic circuit or a processing unit or whatever you want to call it, right? Which is designed to accelerate computer graphics or image processing. Okay. Someone said that it was it helps you do mathematical calculation, which is correct. Initially, it was also designed for mathematical calculation, which is very essential for modern day computing as well. Okay. There are a lot of things that actually GPU enables us. So one is definitely mathematical computation, parallel processing. It has a specialized core that basically enables us to do image processing and all of those things, right? And because it can do a lot of complex calculation at a very high performance, that is why we use it in machine learning a lot. Okay, make sense? Make sense? Say yes. Say yes. Yes, it makes sense. Yes. Cool. No, sir. Okay. GPU equals computer graphics, image processing. GPU equals parallel processing. Parallel processing is in as in running multiple processes at the same time. GPU as in helps you do complex mathematical computation at a faster rate. GPU helps you deliver multi-core fast performance. Now, does it make sense? Okay. So that is what a GPU does. Cool. Now, okay. So obviously, write fast deep machine learning code. Cool. Able to access many pre-built deep learning models. Okay. Um, helps you to pre-process, model, and deploy. Cool. And was originally designed and used in-house by Google. And now it's open source. Cool. Okay. What does GPU helps you to do? It basically helps you perform complex mathematical calculations. Okay, so that is what a GPU enables you to do. It enables you to perform very complex mathematical computation, which is very essential for your machine learning model to work. And especially when we are talking about deep learning, it becomes much more essential because deep learning or basically working with unstructured data requires you to have high sort of performance in your system, okay, which is not achievable technically or practically to do it without a GPU. Okay. And the library that we basically use and the library that helps us tap into using this GPU is TensorFlow. Cool. Now, if you remember how we used to use our model, right? You remember this scikit-learn map that we actually discussed, and I showed you this map that, okay, we can look at it again. So I showed you this map. This is how we used to see, do this, select a model, that what model we are supposed to work on, and so on and so forth. So we can have a very similar sort of a structure for also unstructured data. And we can see, okay, so let's see how to choose a model. Cool. So for example, if you have structured data, okay, you use some model based on the sample size and so on and so forth and make some decision out of it. And ideally, you will use some sort of ensemble algorithm or CAD boost, okay, which we haven't looked into. You can actually explore it, or XG boost, okay, something like that, okay. When you have unstructured data, okay, when you have unstructured data, again, you will have to select some sort of model, okay. And there are two types of approaches that you can apply onto an unstructured data, okay. One is deep learning, which can be achieved via TensorFlow, okay, or transfer learning, which also can be achieved by TensorFlow Hub, okay. This much is clear, okay. Now, what are neural networks? Anyone knows it? Want to define like neural networks? Okay. Assume, it's not an assumption, so you can just say it. So basically what neural networks are, it is basically a system. Okay. Neurons like we have, not really, collection of different layers that include input, hidden, and output layers. Yeah, but you guys are giving very vague definitions. I mean, make it simple for us to understand, or I mean, talk in terms of computer. The definitions are not wrong, but like make it broad enough to actually understand. You are right. Simulating a neuron, interconnection of networks. Okay, I like that. Interconnection of networks. So this is, so basically we have a lot of computed systems. It can be a lot of different sort of systems which are interconnected between each other. Okay, these are all basically interconnected with nodes that work much like neurons in the human brain. If you know nervous system, how it is connected with like all different parts of our body. Okay, and what they do is like they use a lot of algorithms to recognize hidden patterns and correlation. Okay, in raw data, cluster, and classify it over time, continuously learn and improve eventually. Okay, so you know how human body works. The human body does not know everything like since the beginning. We basically learn progressively and adapt. Correct. So that is what enable us to eventually achieve and do complex tasks. Yes, what is your question, Roshan? What is your question? Don't say, sir, I have a question. Just ask a question. How to make a project? I don't know what do you mean by how to make a project? Okay, you have very vague question. When you are clear enough and like broad enough, I can answer that. I can't just answer how to make a project. I can say you can make a project by coding that. So, but I can't answer vague question. Okay. So what kind of problems we can solve with deep learning? Guesses? Guesses what kind of problems we can solve? Again, it is very vague because we have already covered all of this thing, Roshan. I don't know. You're asking the question which has been pretty much explained both in recap and in like 3 classes before, how to create a project in AIML. And even now we'll be doing that. So I don't know what you mean by that. Okay. Object detection, face recognition, image classification, object recognition, blah, 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 blah. Correct. But probably we can, object detection, image recognition are the same sort of thing. So we can broadly classify it in this way. Okay. So there are 3 things that you can do. One, you can either do some sort of classification problem. Okay. And okay, what is the classification problem? Classification problem are where like you already have some sort of label data and then you can classify into some sort of category. Okay, so those are the classification problem that you can basically solve with deep learning, especially on top of unstructured data. Okay. Another problem that you can do is sequence to sequence problem. This is more sort of a problem where like you're trying to find something nearest to each other. For example, when you say, hey Google, where is the nearest cafe? And then basically Google understands and then answers you, okay, the nearest cafe is somewhere here. So it is a sequence to sequence problem where like basically it matches all the relevant nearby nodes and gives you a prediction. Okay. Or we can do object detection. Okay. So what type of object is there in a very complex image? For example, in an image, there can be a bicycle, there can be a dog, there can be a lot of different things, and we can detect all of those different things. You might have seen a lot of mini projects where like people are identifying different type of objects, and these are the things that we can do. Okay, so these are like broadly three types of problem that we can actually do with a deep learning and many more. Okay, now what is transfer learning? Okay, what is transfer learning? So I already explained this. Let me explain you again. So what you do is you take what you already know in one domain and then apply it to another domain. So assume, let's just say you want to predict speed of a car. Okay. Now imagine speed is a feature, okay, which you have studied a lot, okay, but you were doing that for some another domain. Probably you were analyzing something like mass distribution or whatever, like some other sort of metric in similar sort of data set or different type of data set, and speed was a feature that you were studying around it. Okay. So maybe you were basically studying speed in traffic zone in a specific country, and now you want to predict the speed of a car in basically non-traffic zones. You can transfer that traffic zone learning into a non-traffic zone learning. Okay. Or maybe this is much more closer example. You can even take that speed, use that learning to actually predict distance, right? You can do that. You can apply certain learnings from another place to predict something else on another place. So you can do a lot of these things. So it can help you solve some really complex issues. Okay. Now sometimes starting from scratch. Okay. Can be expensive and it can be time consuming, right? That's why we want to use transfer learning so that we don't start from scratch over and over. We want to basically be limited on what we are doing and how we are starting and how we are solving a particular problem. Okay. So how do we do it? Why not take advantage of obviously what we have already done? We don't want to redo everything from scratch. That is why we take advantage of things that we have already done and we use the same learning, and that's what we do with scikit-learn. Okay, now if you remember our scikit-learn workflow, what we were doing. Okay, um, cool. In our scikit-learn workflow, we used to get our data ready. Where like we used to basically polish up our data. If it had some missing values, we used to hot encode those missing values, or then maybe polish. If we have object type, then we used to convert it to numerical types because we can only make predictions on numerical data types and so on and so forth. So we used to get our data ready. Okay, so that is common thing between like TensorFlow and scikit-learn, that we make our data ready. Okay. Then what we used to do? We used to pick a model because now we have studied our data. We basically made our data ready. We already did some data analysis and we now know our use case. Okay, this is how we are supposed to do it. Cool. But now the second steps comes that we need to pick a model. Scikit-learn gives you a easy, basically approach to pick a model. In TensorFlow, you will have to do make much more effort. But the idea is same, that you basically pick a model. Oops. Pick a model. Pick a model that suits your problem, right? What was the third step? Third step was fit the model to the data and make a prediction. That is what we were doing in scikit-learn, right? And then we have to do the same thing here. We need to fit the model to the data and make a prediction, right? What was the fourth step? Okay, tell me. I won't move to fourth step. You guys have to tell me. What was the fourth step in scikit-learn workflow? What was the next step, guys? Not accuracy. I mean, accuracy is right, but not accuracy. Give a broader term. Broader term for accuracy. It's not just accuracy. Model validation, yes, but broader, like some other term. It is correct. Model validation is correct. Evaluate the model. Correct. Evaluate the model. So we evaluate the model, which is same as model validation, right? We evaluate the model. That is our model correct or not? What is our accuracy? What is the precision? If our FN value is correct, if our support levels are correct, and so on and so forth. Okay, or our R square metric, if it is a regression thing, our R square metric or MSE or MSA is correct or not? Like, what are the metric measures that we are getting? Okay, is it under the we are getting a prediction level or at which we are satisfied enough, or we should try some other model, or we should improve our data set? What should we do as a basic next step? Okay, that is what we do. So we have to evaluate the model. Once we evaluate the model, what do we do? Once we evaluate the model, what do we do? What is the next step? I mean, during evaluation of the model, we do testing. Hyperparameter tuning. Okay. Experimentation. We do experimentation. Okay. We do experimentation and keep on improvising our predictions. Okay. And improvise our prediction levels. Right. We do experimentation and improvise our prediction levels. Cool. And finally, we save and reload or reuse our trained model. This was the same workflow that we were doing for scikit-learn, and this is the same workflow that we will do for TensorFlow. Okay. What we will cover in this whole process is, obviously we'll do this end-to-end multi-class classification problem with TensorFlow. We'll do some pre-processing of image data. We'll experiment with deep learning model. We'll try to make fitting. We'll make prediction. We'll evaluate. We'll say. So we'll actually follow this whole workflow and we'll try to do it. Okay. We will work on this same Kaggle data for dog breed prediction. Okay. If you don't have a good GPU enough to support your prediction using TensorFlow, I would recommend that you guys can go on Google Colab and use that. Using Google Colab, you can possibly work on all these things. By the end of this deep learning topic, I'll share you this notebook. Okay? Okay. So ideally on local machine, you do this whole mini conda thing and stuff. With Google Colab, you don't really need to have mini conda and all. It usually comes pre-installed. Okay. And if you want to save the notebook, you usually get this whole notebook sort of extension, which is IPYNB. That is what you can use and save. So you don't have to worry about it. Cool. So what is activation and what is loss in deep learning? Anyone knows about it? I mean, even if you don't know about it, it's completely fine. But I just want to know what is activation function and loss function in deep learning. Anyone who can answer is good enough. Just take wild guesses. Parameter tuning. Okay. You don't really need to know. It's completely fine. But this is correct. Parameter tuning is actually correct. Okay. Is used in hidden layer and takes input with weights and bias to produce an output. Okay, this is much more broader sort of definition, but the idea is the same thing. We are doing some sort of parameter tuning. Okay, that is why we need this activation function, loss function, okay, to have some form of metric to evaluate our predictions. Okay, there are different sort of activation functions and loss functions. For example, for activation function, we can have something called as linear function. For loss function, we can have mean squared error, which is very similar to what we looked into our regression problem. Okay. Yes, and someone said here's sigmoid and stuff. So, and stepnoid. So those are the things that we can have. And they all have different sort of mathematical formula. Obviously, we won't be covering all of those maths into it, but it's just good to know. You can read it or by yourself eventually. Just good to know that, okay, these are the things. Okay. So for example, in binary classification, we can have activation function as sigmoid. Now you can look into the math of it, and then loss function as like binary cross entropy. Okay. For multi-class classification, it can be activation function can be softmax, and then loss function can be categorical cross entropy. Now, again, there is a maths in it, which involves and helps you measure things around it to make your evaluation criteria, and you can look into it. Okay, how it internally works. Cool. Cool. Now, if all of this is clear, okay, we can finally look into something that we will learn. Cool. Okay. So what we will do with our TensorFlow project, okay? We have a breed sort of data set, okay, which we got from Kaggle. And what we'll do is we'll basically try to evaluate those data sets, okay? Let me see if it is the right data set that I have. I need to know if I have the right data set. Don't even know if I have the right data set. Okay, cool. I have the right data set. So what we will do? We will do end-to-end multi-class dog breed classification. Okay. The idea is we want to identify the breed of a dog given an image of a dog. So basically I will provide any sort of image of the dog and we are supposed to predict it, what breed of the dog it is. Okay. The data set, you can get it from here. Cool. Okay. When you actually go into this particular link, you will download, it is somewhat around 700 MB of data set. Okay. And you can download this data set. It has somewhere around 10,000 plus images. Okay. With multiple features and stuff. And you can unzip that and then start working on it. Like I already said, if your system supports and it has a good GPU, you can directly start working with your Jupyter notebook, which is present locally. If you don't have a good GPU, okay, then you are supposed to use Google Colab. Roshan, you will have to have patience to know how we will do it. You need to download the data set and I need to start working on it. I'll show you as we proceed. Okay. Why do I feel that it is your first class though? I think I'll have to install a TensorFlow. I haven't installed TensorFlow here because, yeah, for whatever reasons, I didn't install TensorFlow. So we will have to look into it. Where to copy the link? Which link? Which link? Which link? Let's see, do we have TensorFlow or not? I feel like we don't have TensorFlow. Okay, yeah, we don't have TensorFlow. I'll have to install it. So, guys, you guys remember how we install this new package every time? Last time we discussed how we install it. I wrote it in the first class itself. The one who's saying pip to install, I'm really sad for you that what you did throughout this whole class. Are you guys literally literally telling me that we need what? Pip, right? Conda install TensorFlow. Okay. Give me 1 minute. Give me 1 minute. Guys, give me just 1 minute. Okay. Just 1 minute. I'll be back. Okay. Okay, guys, I'm back. Okay, so um, let me run the notebook again so that we have it. Okay. Um, let's see. Page. Okay. Cool. Let's see if this works now. Okay, it does. So I'll write the installation process. So it doesn't. TensorFlow Hub, it says requires TensorFlow version. Um, cool. So ideally, I mean, it's not working for me because of some version discrepancy. The ideal thing was like it was supposed to work. But I'll tell you how we are supposed to install it, right? Okay, let me let me go there. Okay, you use this command, okay, to install TensorFlow Hub, and then you use technically this command using conda install your TensorFlow. Okay, so these are the two things that you use to install TensorFlow in your system. Now, let's test it one by one because I think we might be mistaken here. Okay, it does not throw any error with TensorFlow at least, but it throws an error with TensorFlow Hub. So let's see if you're good on TensorFlow Hub. It says we have TensorFlow. Okay. Hmm. I need to debug this. Give me just 1 minute. I'm not even sure why I'm getting this because this was supposed to work. Okay, let's try to get TensorFlow version. Okay, it is 2.16. Okay, and on the uninstall. Okay, sadly, I think it is not available via Conda. Uh, via Conda, we are not getting the exact version that we are supposed to get. Hence, someone was actually telling me like which version we can get. So probably we can use pip and see if it works. Mm, No, we won't try Google Colab. We just want to make our local system work because it's essential that it works locally. Um, Before like trying something else. That is the last option that we'll do basically. But definitely if it doesn't work, then I'll have to use Google Colab, but I will have to upload 700 MB of data. Yes, guys. Meanwhile, if anyone has any other question, okay, while I'm trying to fix up the installation process, okay, um, you can ask me right off the bat. Will you give information about our selected domain in doing project? I mean, depends. Like if you want to ask me about something specific, I can definitely give you that. Mm, okay, if it's not, if it takes more than 2 minutes more, then we'll just switch to Google Colab. And probably I'll show you the same stuff tomorrow and I'll make it work on my local system. Because I want you guys to know how it works on locally, which I actually wanted to, and I thought it will work right off the bat. It was in my earlier versions. but now it's not. So probably I messed up something. What project? Like, what do you actually want to know? I keep saying like, don't ask vague versions. Like, just can you guys be very precise on what you're asking? It depends what kind of data set it is named. If you select like Spotify likeliness, okay, depends. I have given you all the tools, right? So you have to actually understand what sort of data set you have and so on and so forth. If you don't understand what type of data you have, then it becomes a bit of a problem. There are so many data sets. You can actually look into Kaggle, Neha, about fake news detection. Okay, I think so. I installed it. I think I installed it, so it should work. Yes, you can use. You can definitely use PyTorch. Okay. Um, uh, I don't know where the previous session's video link is. Okay. Um, but let's see. Okay. If you have any specific question regarding previous session, you can ask me. It's completely fine. Cool. Cool. Let's see if it works. I don't know if it works. So let's see if it works. I hope it works. And probably it doesn't work. And yeah, probably it doesn't work. Can we install PyTorch rather than installing TensorFlow? I mean, it's completely up to you what you want to install. Mhm. Let's try to restart this and see if it works. I mean, I don't know where the data set is. I mean, probably there should be some data set on Kaggle and you will have to find it out. I can't just say, okay, there is this data set and so on and so forth. You will have to find it out. What Telegram link do you need? What Telegram link do you need? Okay. Guys, okay, so why it is not working is apparently TensorFlow has a much later version, okay, but TensorFlow Hub is not really updated via Conda. It has only 0.12. That is why it's not working as we expect it to work. Probably the possible solution is that we'll have to actually lower down the version that we are working on, and that's how it will work. That is so that's the probable reason why it's not working. So what I'll do is I'll possibly try to install TensorFlow but at lower 2.8 version instead of 2.16. Okay, and hopefully then it should work as it's supposed to work. Okay. um And a bigger problem with that is that I have Python 3.12, and that is why it's not working. Okay. Yeah. So I also have to lower down the Python version. So, okay. For now, temporarily, what we'll do is let's just explore Google Colab. Okay. And see what we can do around it. Okay. So, okay. I'll give you a walkthrough of Google Colab, and probably tomorrow we'll just do the coding. I just wanted to show you how it works locally, but sadly I'm not able to do that. Uh, so instead, what we can do is like we can explore this. So what you have to do, you just try to create a new notebook. Okay. And cool. You see, I'm already logged in, right? Um, in here, you will see all of that thing. Okay. So you can pretty much do the same thing in here. Okay. Now, if you if let's just see what version of TensorFlow we already have. Okay. 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 So okay, that's why I was not happy enough using TensorFlow on Google Colab because it is very slow, as you can see. Okay. And let's try to, okay, let's try to check on TensorFlow Hub version. Okay. We got this. Maybe it's not working as I expect it to work on Safari. Let me change the browser. Probably it's not so compatible with Safari. Okay, let's try to do this. I think my screen is visible, right? Guys? Okay, cool. We got this. We also have TensorFlow, right? And we can now wait for like to see, okay, how it is working and so on and so forth. Right? We see that we have 0.16.1 TensorFlow Hub. We have 2.15 for TensorFlow. So it is all working, right? It is all working. We can also check on the GPU metrics and see like how it is working and so on and so forth. Cool. And it says, okay, GPU is not available for whatever reasons. But you can see this and everything, it is basically available to us. Okay. So we need to make sure that we are, okay, connect to a hosted runtime. Okay. So there are multiple options that you can see here. We can use local runtime. We can use hosted runtime. We can use a custom GC. Okay. And you have multiple options in here. Okay. We can create multiple sections to actually work with. then this is the place where we can get data. As you see, we have some of the sample data, okay? But for example, in this particular case, we are supposed to get data from like this whole our drive data. So what we are supposed to do is like connect our Google Drive, okay? Sadly, with Google Colab, I won't be able to do it because today I don't have this data uploaded. So what we'll do is I'll have everything ready by tomorrow, and we'll probably cover everything, okay, on this data. So I have a lot of things in here, probably not an ideal place uh, to get a new data, but what we can do is I'll just upload this data that I am supposed to, and then we can do it. Okay. So dog breed identification code, and let's just say. So it takes a lot of time. Like I said, I won't be able to show it today. I'm sorry for that. I'm sorry for the hiccups. I was not expecting a version conflict, to be honest, in this class. I actually tested it with lower version before this. That is why there's this problem. What you can do right now is ask me any questions around deep learning if you have. What we'll do is like tomorrow we'll be basically complete all of it, and I'll be very much prepared with the data set and everything locally. So it should be fast enough for us to complete through like this whole process. Okay. If you have any questions, you can ask me. I'm again sorry for the this hiccup of not able to actually run through TensorFlow. Any questions, guys? Any questions around deep learning? You have to understand though one thing that the how TensorFlow works is very similar to how we were doing the scikit-learn stuff. Okay, even the functions and all, you will find a lot of similarities. If you attended previous class, I would say it is much ideal for you guys to actually go through that class, okay, and cover up everything that you are supposed to cover up, okay, um, because it will help you a lot actually doing all of those things, okay. How to create a project and how to convert to CSV in a data set. I already said that I mean, how do you create a project? You basically create a new Jupyter notebook. That's how you create a project. And you eventually use some sort of library like Pickle or JobLib, and then you save that model after you have created and tested that model. If you look at scikit-learn's whole session, you'll understand how we create a project. How to convert to CSV in a data set. It depends on data to data. If you have some unstructured data, you will have to actually divide that data and polish up that data and have to convert that data. Okay. Difference between deep learning and neural networks. Okay. First of all, guys, answer me again. What is deep learning? Answer me again. What is deep learning? Way to implement ML. I mean, what is up with you guys, man? Wow. The question, way to implement ML. We have covered all of these. These are really basic way to. I mean, what have been we been doing last three classes? We have been implementing machine learning. I do identify whether the data is structured or unstructured. Okay, this is a cool question. Okay, for example, when we have a data in some sort of table format which is easier to read, okay, then it's called a structured data. When we have data set in a format which is not easy enough to read, for example, images and so on and so forth, okay, um, or music, that is called an unstructured data. Okay. Deep learning is a branch of machine learning which tries to uh, implement neural network. Okay. And what is neural network? Neural network basically tries to replicate human brains. Okay. It typically creates a interconnection between different sort of nodes and try to make prediction. Okay. What else? What else, guys? You guys keep asking me like how to create a project. Like, what have we been doing like since last five classes? Unable to import matplotlib in Jupyter Notebook. You have to install matplotlib. Conda install matplotlib, and you will be able to import it. I have already shared entire notebook, Jupyter notes of this entire internship, apart from deep learning part as of now. And I'll share the deep learning part after we are done with deep learning. Okay, you can't use pip, you need to use conda because conda is what is creating your environment. And if you are using pip, then you have to use pip throughout your whole project. And probably you will have to use when then to create a virtual environment using virtual environment. Okay, so there's something called as when, which stands for virtual environment, which you create via pip and Python. It works very similar to conda, but it's ideally recommended that you use conda because it has first class support for a lot of machine learning libraries that you use. Okay, I have already showed you guys how you actually install miniconda. I feel like some people here attended first class and now coming into the last class of this whole internship, and like you are asking me questions from the first class, which also has been covered in a recap, guys. Okay, any other questions? I don't know what you mean by when command. I don't know what is that. Okay. Just ask the question on chat, Rakesh, instead of raising hands. You can just ask the question. Okay. Blackbucks can send you attendance link. Cool. Um, we'll complete the we will complete the course tomorrow. Okay, don't worry about it. I'll complete the course. I'll explain you everything that I'll do in that whole course. So don't worry about it. I'll fix up my installation both locally, and I'll also basically upload everything just in case on Google Colab. The idea is that, so the problem with Google Colab is it works the same as Jupyter Notebook, but the point is that you will have to have the data set actually available on your Google Drive. I was just not doing it because it takes a lot of time to actually upload that data set into Google Drive. It's like 700 MB or 1 GB of data that I will need to upload on there. Okay. What type of Telegram link are you asking? I am still confused. Yeah, I'm legit confused. What is this Telegram link about? Seriously. Not really, not really, Osai. I would highly recommend you guys go to Kaggle. Kaggle has a lot of free data sets that you can use. Exactly. Exactly, Teja. It has a lot of easy access to data sets. You can easily import them for your project. Okay. Ideally, if you need some, you are doing something on deep learning, ideally you use Google Colab if your system is not strong enough. If your system is strong enough, you can use your local system for deep learning. Otherwise, supervised learning just should work out of the box. I mean, Roshan, I can't. I basically took whole Python course. I took there. I already told you you have to do some Google search and need to learn things from by your own. Yeah, I mean, I can't do hand holding on every aspect of this whole development cycle because it will become very vast. Now, I don't know. I don't even know what kind of data set you have. So how can I tell you that how you convert it to CSV data if I have a lot of black box in here? It depends, like it completely depends what type of data set it is. You know what type of data set it is. You have to look for it, like how you convert that particular data set into CSV format or some other readable format via which you can access that data. I was always already wondering by the end of the class we'll ask topic name. It was deep learning, guys. Introduction to deep learning. I have no idea what you are doing, Roshan. You are doing in Excel and in Kaggle, but I showed you things in Jupyter Notebook. Plus, I already had a CSV data. I don't know what type of data you have. If it's XLS X sort of data, I believe it is easily convertible into a CSV data. You can pretty much export it from Excel itself as a CSV format. So I don't know what you are asking. Okay. I'm trying my best to help you here, but to be honest, like I keep saying, there is a lot of black box in here. What you're asking me. To make my project, I searched for data set in Kaggle, but it is unavailable. I don't know what kind of project you are searching for. If the data set is not available, I would highly recommend that if it is a project, you go for a project for which data set is available. The reason for it is usually to create your own data set, it takes a lot of time. You can obviously mock data set and create random values around it. That's definitely doable, but I mean, you might make a lot of mistakes. I highly recommend that you just use available data, which is something easily available on Kaggle. Zero score for what? I don't know. You guys write random statement, zero score available, data set not working. How do I know what the data set you are using? How do I know what is like why you are getting zero score for what sort of file assessment? I don't know. You know it. I don't know. Do you think I'm a god? You'll just write one line and I know everything, the whole context. It's not possible, right? I don't know what file uploading assignments. Okay. I remember giving some assignments which was completely based off like heart disease data set and a housing data set, or I think so wines data set, which is technically already available inside scikit-learn. So I don't know what you are talking about. You're not supposed to upload it. It is already present in the same directory where you basically create your project. I already showed all the setup. If you look into the past previous classes, especially the first classes when we actually started working on matplotlib and everything, you'll see that how we got that data set. You just need to have it in the same directory and it will be available to you. Obviously, you can upload it, but it's just easy. When we are uploading even correct code, it is giving zero score. Probably then the problem might be the with the Blackbucks platform. I don't know. You can mail them, but ideally it should work. Yeah, you can. I mean, for scraping, you can use beautiful soup, scrapey, depending on whatever works. I don't know how you are scraping it, so should work. But most of these platforms I have actually blocked data scraping for free. You can ask Blackbucks if it can be done in groups or you have to do it individually. I don't. You can ask Blackbucks. Okay. Guys, I'll drop now and probably tomorrow we'll finish TensorFlow, I promise, and I'll resolve all the issues in here. And I think so tomorrow will be the last class and we'll be done with our deep learning. Today, I think so the introduction is good enough. And probably those are the basics that you need to know before we start. I coded the heart disease file project in Jupyter Notebook and saved the file. If you are doing the same thing that I did, okay, and you are basically trying to get the same thing that I did, and you are doing it locally, you should not get the score zero. And if you are getting the score zero, I don't know why you are getting the score zero. You should not get it. But if you are saying that when you are uploading something on Blackbucks platform and you are getting that score as zero, then I can understand, okay, it's problem from their end. But if it is something happening on your local machine, then it is not problem from their end. It is basically problem on your end that you are doing something wrong throughout the process. Plus the assignment itself was nothing new. It was pretty much the same thing that we did in the class. You just had to repeat those processes. Tomorrow we'll do deep learning, Roshan. I don't know if you are expecting to cover up like previous classes, that won't be happening because we already did recap. I hope that you actually read through all the previous classes. We have taken 15 sessions. So almost 15 sessions. You should be prepared now. Okay. Okay, guys, I'll drop. See you. Bye.